In this video, we're going to be evaluating compositions of functions. Let's first go over our inverse properties to help us. So here we see that if x is between or equal to -1 or 1, and y is between or equal to -pi/2 and pi/2, then we're able to say that the sine of the arcsine, so sine times the inverse of sine, will equal x, and that the arcsine of sine y will equal y. So our inverse of sine times sine y will equal y. We are also able to say that if x is between or equal to -1 or 1, and y is between or equal to 0 and pi, that cosine times the inverse or arc cosine of x will equal x, and that the inverse of cosine times the cosine of y, or the arc cosine times the cosine of y, will give us a y. We're also able to say that if x is a real number and y is between -pi/2 and pi/2, then the tangent times the arctangent of x, which is our tangent times the inverse of tangent, will give us an x. And the arctangent times the tangent of y, meaning our inverse tangent times tangent, will give us a y. So let's work out some problems now. So we're going to start here. So if possible, we're going to find the exact values of these three things. So we're going to start with A. So here we have the tangent times the arctangent of -5. You might also see this written as the tangent times the inverse tangent of -5. This is what this is saying to us. And we might not see parentheses there. You might even see brackets there. But that's what that's saying. Okay, that's the same thing. And so we're able to cancel out our pieces and gives us a -5. And we know that -5 is the correct answer because -5 is in the domain. So remember that our domain is this piece, right? X equals all real numbers, and -5 is a real number. So we can say that it is a solution. Let's take a look here at letter B. Here we have the arc sine times the sine of 5pi/3. Another way we might see that written as the inverse of sine times the sine of 5pi/3, which allows us to, using our inverse property involving sine, to say that we can cancel those out. Same up here. And that's going to give us a value of 5pi/3. And so we want to see if that sits in our domain. So our domain says that x must be between -1 and 1. But 5pi/3 is not in our domain. So that means that we're going to find the cotangent angle. Excuse me, yeah, the cotangent angle. All right, so we're going to find our coterminal angle. So let's take a quick look at what that might look like graphed. So if we were to graph this, we would have our initial side here, and we'd find our terminal side here. And so if we're looking for that, we're going to start with our 2 pi, and we're going to subtract our 5pi/3. And we're going to see that that is going to give us a resulting value of -pi/3, which would be that angle right there. And that is inside of our value. Now, really quickly, here we have that it's not in the domain, but really what we should be looking at, because this is a sine function, is the range. And we see that 5pi/3 does not sit in our range, but -pi/3 does. And so that is going to be our resulting answer, is going to be -pi/3. And that's going to be our solution. So let's go ahead and let's do letter C. So here we have the cosine times the inverse cosine of pi. And using our cosine property, we're able to eliminate our cosine and our inverse cosine. And that's going to give us a value of pi. Now, because pi is the number we plug in, we kind of have a problem here, because remember, our domain is telling us that x must sit between -1 and 1, and pi does not do that. And so we end up with a problem here, because this ends up being not defined, because pi is not inside of our domain. So remember, pi is approximately 3.14. And so our answer here is going to be not defined. So now that we've gotten a little bit better at using our inverse properties, let's do some composition of functions. So here we have the tangent times the arc cosine. Remember, the arc cosine is the inverse of cosine. So what we're looking at here is the tangent times the inverse cosine of 2/3. That's what we're looking at here. So what we're going to do, we're going to use our arc cosine, but we're going to use some u substitution. So we're going to let u equal the arc cosine of 2/3. All right, so let's use a different color so we can kind of follow this a little bit easier. All right. So what we're then able to say is that the cosine of u equals 2/3. Now, because the range of the arc cosine function is from 0 to pi, meaning, remember, our first two quadrants, and cosine u is positive, then u is a first quadrant angle. And so we can sketch and label an angle u to do that, to help us out. So we will sketch in the first quadrant, and we're going to go over 2, because remember, this is supposed to be our x over our radius. So we'll have a radius here. And so we're going to have a radius of 3, and we went over 2, and then that's going to finish creating a right triangle for us. Okay, a right triangle. And we need to find this side length right here, our y value. We need to find that so that we can find the tangent there. So we can do that using Pythagorean's theorem. So we're able to say that y, because we know that a squared plus b squared equals c squared. So we can take 2 squared plus 3 squared, or rather, let's try this again, 2 squared plus y squared equals 3 squared. And so we can find that simply by subtracting our 2 squared from both sides. So y squared equals 9 minus 4. Then we're going to take that square root. So we're going to get y equals the square root of 5. And it won't be the -5 because we're going to have a positive length here. We have a positive length. And so we're going to get a y value that's going to equal the square root of 5. So now we're able to say that the tangent, I'm going to move this around a little bit so it makes a little bit more sense. Hang on. There we go, that's a little bit better. So we're able to say the tangent of u, remember that's supposed to be our y on top of our x. So we'll take our y value, which we know is now the square root of 5, over the x, which is a value of 2. So here we see that the tangent of u is radical 5 over 2, which then allows us to say, by replugging in our arc cosine of 2/3 for u, that the tangent of the arc cosine of 2/3 equals the square root of 5 over 2. And that is our answer. Let's try another one. So here in letter B, we have the cosine times the inverse of sine of -3/5. So because we know that the inverse of sine has to be either in the first or the fourth quadrant, and we have a negative sign here, that tells us that our answer is going to be in the fourth quadrant. So we can do a little sketch here. And remember that sine is the y over the radius. So here we're going to go down 3 units. We'll have a radius of 5, and we're then able to construct a right triangle where we are searching for our x value. Now you might have noticed that, let's see, that's a down 3, that we're able to find our x side. This one's actually kind of easy. If we take away the negative, then it looks like a 3, 4, 5 triangle. So it's Pythagorean triple, or you could do Pythagorean's theorem to find it. But so here we're going to have an x value of 4. And we know it's a positive 4 because we're in the 4th quadrant here. We're moving in the positive direction. And that's why we know it's a positive 4. So from here, we want to go ahead and plug in our u. So we're going to say, all right, we're going to let u equal our inverse sine of negative 3/5. It's going to kind of hold that place for us. So now we're able to say that the sine of u equals negative 3/5. Now if you're wondering, like, well, why can you say that? I don't understand. Now think of it this way. This is like saying the sine times the inverse sine of negative 3/5. And we just did up on our properties that those cancel out, leaving us with just the negative 3/5. So that's why we're doing it. We're plugging in that u to be able to get that negative 3/5. And that ultimately is what allows us to take this piece and to create our triangle. So from here, now that we have our y value because of the Pythagorean triple, or your Pythagorean theorem, whatever you chose to use to do that, we are then able to say that the cosine of u equals our 4 over our 5. So from there, we're then able to say that the cosine times our inverse of sine of negative 3/5 is equal to 4/5. And that's our solution. Remember when you're doing these to make sure that you're checking which quadrant you should be in. And we can do that based on our domain or our range, depending on if we're working with cosine, then we're looking at our x's or our domains. And if we're working with sine, then we want to look at our y's or our range because sine is the y.